Let us discuss top 10 questions from solid state. The number one is the value of D111 in a cubic crystal is 325.6 picometer. The value of D333 is,
for a cubic system, d scale would be a upon root over a square plus k square plus l square. Okay, for D11 system would be a by root over 1 square plus 1 square plus 1 square. So here you can write a by root over 3 for D11, or root over 3 D111. Or you can say, or for D33, a upon 3 square plus 3 square plus 3 square equal a upon root over 27. Okay, or we can write 3 root over 3. Now put the value, above value actually. Put the above value into this equation. We have root over 3 D11 upon 3 root 3. So root 3 into 325.6 upon 3 root 3. Root 3 root 3 cancel. So answer would be 108.5 picometer. This is the final answer.
number two questions. The structure obtained when all the tetrahedral holes are occupied in FCC structure is of type. In AX2 types of crystal, all the tetrahedral sites are occupied in FCC structure. Three questions. The angle between the two planes represented by the Miller indices 110 and 111 in a simple cubic lattice is.
Here, the angle between two planes having the Miller indices H1, K1 and L1 and H2, K2 and L2 is given as cos theta equal H1, H2 plus K1, K2 plus L1, L2 divided by root over H1 square plus K1 square plus L1 square into H2 square plus K2 square plus L2 square. Since Miller indices are given 1, 1, 0 and 1, 1, 1, so putting this value in this equation, we have 1 into 1 plus 1 into 1 plus 0 into 0 and root over 1 square plus 1 square plus 0 square into 1 square plus 1 square plus 1 square. By simplification, we have 2 root 2 into root 3 equal root 2 by root 3. Root 2 by root 3 is equal 0.816. So cos theta equal 0.816. So theta equal 35.31.
Number 4 question. The packing fraction of a simple cubic lattice is close to.
4 question. Packing fraction equal number of particles per unit cell into volume of one particle divided by total volume of unit cell. For simple cubic lattice, number of particles per unit cell equal 1 and volume of particles equal 4 by 3 pi r cube and total volume equal a cube. We know that a equal twice r for simple cubic. By simplification, we have r cube cancel equal 0.52 is the answer.
Fifth question, the coordinates for the atoms in a body-centered cubic unit cells are?
When coordinates are changes with one axis, the unit cell is simple cubic. When changes with two axes, it is face-centered cubic. Thus, when coordinates are changes with three axes, then the unit cell is body-centered cubic. So answer is body-centered cubic.
Number 6 question, the interplanar distance in angstrom for 100 plane in a cubic structure with the lattice parameter of 4 angstrom is?
For cubic system, interplanar distance is given as dh square hkl equal a square by h square plus k square plus l square. Here a equal 4 and h equal 1 and k and l equal 0. By putting this value, we have the h square hkl equal 4 square divided by 1 square equal 16. So DHKL would be 4 and 4 is the answer.
Number 7 question, length of the side of the unit cell for lithium is 351 picometer. Its atomic radius if lithium forms body-centered crystal will be?
In body-centered cubic crystals, atoms touch one another along the cross diagonal of the cube. Thus, 4 are equal root over 3a, or r equal root over 3a by 4. Here, a equal 351 picometer. Thus, r equal 151.9 picometer. And this is the answer.
Number 8 question, in a FCC arrangement of A and B atoms, where A atoms are at the corners of the unit cell and B atoms at the face center. One of the A atom is missing from one corner in each unit cell. What is the formula of the compound?
Here, number of atoms A from each corner of unit cell is 7 by 8 and number of atoms B from the faces of the unit cell is 3. Thus, A is to B equal 7 by 8 is to 3. So that we can write the formula as A 7 by 8 B 3, or in simplest ratio we can write A 7 and B 24.
Number 9 question. The coordination number of the barium 2 positive ion in barium fluoride is 8. The coordination number of the fluoride ion is?
Barium fluoride is a AX2 type salt. In its crystal, barium 2 positive ions are arranged in CCP arrangement. Since there are two tetrahedral sites for each barium 2 positive ion and fluoride ion occupy all the tetrahedral sites, there will be two fluoride ions for each barium 2 positive ion. Thus, each fluoride ion surrounded by 4 barium 2 positive ion, that is, the coordination number of fluoride is 4.
Number 10 question. The band structure in a n-type semiconductor is?
Number 10. This is because a large energy difference exists between valence band and conduction band. In case of a semiconductor, an addition of an impurity results in the n-type semiconductor.